Ready to see AI agents work together like a digital consulting firm? Imagine business tasks handled with coordinated intelligence, instant status updates, and full context memory, all visualized live. Dive in. If you're still using old FANG prep guides, you're already losing ground. The rules have changed, and this free AI playbook shows you what's really being tested in modern FING interviews. Insider strategies, hidden evaluation matrix, a 90-day mastery plan. The exact playbook successful candidates are using right now. Everyone's grabbing it. Don't be the one left behind. Link in description.
Alright, as I said, we are going to now build a production-ready multi-agent system that demonstrates enterprise-grade AI orchestration. We'll examine every component from the ground up, and then we talk about basic concepts like nodes and edges to advanced patterns like async batch processing and real-time state management. So just to give you an overview of the system, let me first quickly just show you the system that we are trying to build here. This system processes complex business tasks by coordinating multiple specialized AI agents through a standardized protocol like MCP, Model Context Protocol, and you can think of it as building a digital consulting firm where each agent has expertise in strategy, research, analysis, and creative problem solving. And you can see that we have a Python code and it mimics some mainframe job control, and we actually connected the whole thing to a web interface. We have scheduled agents job run, and we have job status tracking. We output all of the agent communication to output files, and then we also have some UI response as a result here. So just to let you know and walk you through the code and learning experience, one thing to talk about is what are tools in AI systems. Tools are external functions that AI agents can call to extend their capabilities beyond text generation. And here I have two sets of tools, and I call them calculator tool and researcher tool in this case. So why does these tools really matter? AI models can only generate text, but tools can let them perform actions. Tools provide deterministic and reliable functionality. They enable AI agents to interact with different databases, API, calculations, file systems, and they are a bridge between AI reasoning and real-world executions. So as you can see, we have created an array of tools, and I included both of these tools in my array of tools. And then we have the tool node that takes this array of tools, and the tool node is actually one of the sub-libraries of LangGraph pre-built type of tools here. Now, what are nodes in LangGraph? A node is a processing unit in your workflow that takes state as input and returns modified state as output. So you can see in this code, I have an executive agent, and this executive agent, you can see that is defined here, is part of my nodes, and we actually have the different node registration sections, and we can keep adding node to our workflows. We have multiple nodes that I defined for our agent states. We have an executive agent, researcher agent, analyst agent, creative agent, and a coordinator agent here. So we do register the nodes, and then after that, nodes are pure functions. Some input always produces the same input, always produces the same output. They can call external APIs, use tools, or invoke LLMs. Each node should have a single clear responsibility, and they can directly communicate. All communications need to go through states here. The other concept that we need to be familiar with are edges. Edges define the flow between nodes. They determine which node runs after which node. So you can see that we have a set entry point, and then after that we keep adding different edges to our workflow here. So we have different types of edges. We have regular edges, always execute. We have conditional edges that are route based on state content and create dynamic flow. And we have a start and end edges that you can see. We have an end edge here and we have a start point here. So we basically, this part just explains the complete graph of our workflow here. Then we need to deep dive into state management. So we have a class here called agent state. And actually, let me jump to the definition of agent state in the code. You can see here. And this agent state actually has the tasks and the context, the messaging that we want to set, the output, and what will be the next state that we need to go through. And usually we have an initial state that we start from. We can say analyze AI chatbot ROI. We can create a state after execution of this one and several, after researchers start, etc. So we can actually create multiple states and multiple scenarios in this case here. So let me just quickly show you the code. So we also have a state persistence, and the state object travels through every node and it accumulates results and maintains full context of the workflow execution. Now let's jump to the actual part that we are all here for, which is the MCP protocol architecture. So MCP is, as we mentioned, a standardized modern model control protocol. It's a standardized communication protocol, and it allows different AI models to interact with external tools and services through a structured infrastructure. So we actually create a server in this case, and I can actually jump to our server code, and you can see we have defined multiple points for our server. We have imported the server from MCP package, and you can actually install it using MCP LangChain LangGraph package with a simple pip install command. And you can see here that we have defined a multi-agent batch MCP. You can give it any sort of name that you would want to, and you can actually create the different types for that server here. So we have the types and tool here. We can list the tool, and we can actually create several functionalities. You can call listing tools or going through whatever functionality that you want to create here. So you can see here for list tools, we create types, we return types.tool, and it returns the different tools that we have in our AI system. And you can see the description, the input schema, which actually shows how MCP is useful by communicating all of these AI agents in our process here. So you can have, a list tool, which gives you can see schedule batch or run analysis or list jobs or get jobs, whatever functionality that you want to have. And then you can actually go through the tool invocation. You can have a function called a call tool here, and it handles the tool execution request, what sort of request your server can take into place, can it take a tag, and then what sort of arguments it can get. And remember, it gets the list of the agent, the name of the agent, the context is very important, because the whole benefit of MCP is that it provides communication between all of the agents. The agents have memory, they don't need to start from scratch. So this context keep moving as part of the state here. And we also have the type of the task that is going to get defined here. The other part that I need to also go through is that the code, the structured response and request formats that happens between these different agents in this case. So all of the communication goes through a JSON RPC formatting, which provides clear communication capability, and everything actually has a place. It's structured, and the more important thing is that this can actually be used for the auditing and logging at a later time, which is going to be helpful for different purposes. And then we actually want to compare a little bit. If we had a traditional REST API, we would, for example, had a post request and we would return a result as part of that post request. But now that we have MCP, we could just simply call the tool, and MCP has several advantages. It has the schema validation. Input parameters are automatically validated. We have tool discovery, and clients can dynamically discover availability, available functionality. It's standardized. It can work with any sort of agent, and the output type is JSON. It prevents runtime error and basically provides a lot of capabilities for us. So, for example, you can see that we have a run analysis part, that here the run analysis is actually defined, and it is it is a synchronous tool. It provides immediate response for you. And we also have an asynchronous tool, which actually is used for scheduling the batch jobs in this case. So scheduling the batch jobs is asynchronous, and it queues jobs for background processing step here. So then just a little bit about the LangGraph deep architecture analysis. It is, as we mentioned, it has nodes, it has edges, and it has a state. And the process is that we start, then we call the executive agent, then we call the researcher, then analyst, then creative, and then coordinator, and finally it ends. And the reason that we chose DAG is because there are no cycles. It prevents infinite loops. It has predictable execution, and it also enables us to do state tracking here. So there are a lot of different, types of edges that we can add. We can have conditional routing, and we can have, let me show as part of the code. That we have a parallel processing. It can be more advanced. We can have different, here we can have, a researcher agent. Once it is, for example, finished, we can create multiple other agents starting at the same point. So it is a state graph, and it basically provides the capability of any sort of graph that you would want to have here. So we also, have the job status tracking here in the MCP server that we built. We have the schedule jobs section, and the MCP tool can create multiple jobs in the background. And we also have the capability of the listing all of the jobs here, and it helps with job status tracking. And finally, I just want to quickly show you that in order for the demo, we just created a web server, MCP. It's kind of like a WebSocket communication. It gets connected to a dashboard that is a simple HTML file, and it spits out all of the coordinations, and you can see how they are talking with each other. There is like a WebSocket messaging that gets communicated. I will also show how these agents are going to communicate with each other. And finally, I can actually show you that just by simply, running the web server, it opens a communication, and we can see here the visualization that is provided in this case. You can see the different agents that we have, and you can see all of them are waiting. It captures all of the agents that are here, and then we click simply start analysis. Let me quickly refresh here. Let's open the connection. connected to multi-agent backend. Alright, now let me just quickly show you the demo here. You can see that by just running the web server Python file, it opens a simple web page, which is localhost. And here you can actually see that it recognizes we have 5 agents, and all of the agents that we created here, it is connected to the backend, and we can say start analysis. And you can see the agents are communicating with each other one by one, and they're getting kicked off as we go through here. And then since the job was really simple, all of the jobs are now completed, and here are the messages. You can also schedule back jobs. Since the jobs are really small and the agents are quick, the batch jobs quickly go through, but at some point if I click too much, you can see that it even has the capability to queue some of the jobs, and you can also see the messages that are used in order for all of these agents to communicate with each other. So as you see, again, one more time, we had an application, and in the application, we created a whole set of multiple agents that want to talk to each other using the LangGraph and the tool node. There are several agents, and they talk to each other and they communicate with each other. One agent starts after another agent. And then we created and the definition of all of these agents and what they do. We can call any sort of LLM that we want, and we simply used an OpenAI call for each of the agents. As you see, you can get your OpenAI key from the OpenAI website. And we also have the get agent states here, which helps with the communication of these agents. Then we have the MCP server, which does the job of communicating between these agents. It gets the states, it shows what is the status of the jobs. It can be running, queued, succeeded, or failed, and you can actually see when the jobs are completed or finished with success, or at some point they can also fail as well. Like if I open just the framework and try to get connecting to the agents, that it can get connected, the process gets failed in this case. And you can also see that we have the MCP tool registration, and it will give us different capabilities. You see these buttons are connected to these tools. We either get a job, get it a status, or call different agents in these cases. The other part is simply a web server that connects the whole experience to a UI for us. And on top of that, we have a test file in this case. And just because you may want to, debug your code, we have a test file, and it has, and runs multiple tests in this case, and gives us the capability to, be able to check the functionality of our code here. So we can upload the test case, and you can, use it in your own time here. So just going back to recap all of our learnings here. And so you saw the agent in this case, how it runs, and then you saw the demo architecture. We have we have Windows encoding, we had thread safe asynchronous of the job, and then we have the MCP batch processor gets actually the API client, the batch job, all of the statuses through JSON formatting, and then gets connected to a simple UI for the sake of the demo here. And we had multiple jobs. You can include your own job. You can have a daily summary news, weekly email status, or system performance report, or in our case, we had a whole consulting firm in our use case. So you can see that the flow, we trigger a job, it creates a job UUID, and we asynchronously execute the job, and call after the job is finished. We save the logs in an output, which I show you in 1 second, just so you can also see how the output is provided here. Just quickly opening one of the JSON files. Since the message keeps communicating in the backend, you can see there are multiple worker jobs that are finished and each of them have an ID, but they are running in the background, and that is actually causing the system to be a little bit slow because all of these are talking to each other, and each message is actually being stored in the output log here, which I quickly show an example of the output log. You can see, for example, this one, editing with Notepad++. And you can see a sample of the output. We have the model, the duration of the job, the timestamp, the token, the agent type, what agent actually called it. These are the metadata. There are, the context, the title of the content, and this is AI generated content because we simply just giving it a prompt, and it's an agent that just does analysis and is doing consulting firm, but also has every possible information that we need along with the job ID, and that is how all of the agents are orchestrated and communicate with each other is through that UID that we talked about. I hope you enjoyed this demo, and thank you so much for your time. Please register for our webinars and let me know if you have any questions. Happy to connect.
If you liked this video, you will love what I have to say next. The 14-week agentic AI program at Interview Kickstart helps engineers build real, career-ready skills. You'll work on 2 live projects with FANG instructors and lead with portfolio work that actually makes a difference in hiring. Over 20,000 tech professionals have already trained with Interview Kickstart, with many moving into roles paying upwards of $300,000. Want to learn more? Join the free upcoming webinar, ask questions, meet the instructors, and see if it's a fit. Not ready yet? No problem. Start with the agentic AI building videos here on the YouTube channel. We recommend this one. Either way, the key is to just get started.